Hello, so I'm Alex G, and my project was on creating a more efficient biofilter for use in aquaponics systems. And I work with Live Local Organic to do my research. They're an aquaponics company located just outside Portland. So currently we're going to be facing a pretty big crisis when it comes to food production in the future. The UN estimates that the majority of our topsoil is going to be depleted by the year 2080. And why this is important is because the FAO estimates that 95% of our food is grown using topsoil. And so if we want to be able to feed ourselves in the future, we're going to need a method of farming that isn't reliant on fertile soil. And this is where aquaponics comes in. So aquaponics is a method of farming that combines fish, plants, and nitrifying bacteria, and it's really based around the nitrogen cycle. So the fish produce ammonia with their waste. The nitrifying bacteria take that ammonia and turn it into nitrate, which the plants then take up as plant food, and in the process they clean the water for the fish. So while aquaponics is good because it has a renewable source of nutrients internally, there are also a lot of problems that come with it, especially in a lot of commercial systems. And one of those big problems is that a lot of times these systems don't have enough surface area to house all the bacteria they need to convert all the ammonia they have. So how you get around this is you build an external biofilter, which pretty much just acts as a dedicated house for the nitrifying bacteria to live in. And the biggest thing you want for this is a lot of surface area. And how this is done is that you get biomedia, which looks something like this, and it's pretty much a bunch of small objects that have a ton of surface area. So if you have a biofilter like this, these are the two models I came up with, the top-down biofilter and the side-to-side biofilter. All you do is you pump water from the fish tank into a vessel that is filled with these bioballs, and then the nitrifying bacteria will just take all the ammonia in the water and convert it to nitrate. And so over the course for the 4 weeks that I measured these biofilters, or the 4 weeks that I had them attached to the systems at Live Local Organic, I measured all these quantities, but really the most important thing to pay attention to is the ammonia, because this is what's going to become toxic in high amounts, or in small amounts rather. And so using this expression, I took the ammonia values and I got kind of a minimum nitrification rate for each biofilter. So this is really just to determine the lower bound of the efficacy of every biofilter. And so if we look at the results, the graph here, you can see that so I plugged in the biofilters on the 13th, so right about here. Then after about a week, they started to reduce the ammonia levels. And really the one to pay attention here is this orange one, the side-to-side biofilter, where you can see an immediate drop of roughly 12 parts per million ammonia. This is quite substantial, especially for the small size of these biofilters. And so this is what gave me the highest nitrification rate at just over 700 grams of ammonia per cubic meter of bioballs per day. And if you compare this to a commercial system, you can see that's well within the range that commercial systems operate at, which is roughly 600 to 1,200 grams of ammonia per cubic meter per day. And if we scale up my biofilter for volume, to make the same volume as this commercial biofilter, it's actually $400 less than the commercially available option. And this is actually the option that Live Local Organic is using. So it's really cool for me to be able to compare my system against a commercially available one and see how it was actually a lot better, especially with parts just built, or just using parts that you could get from Home Depot. And looking towards the future, I actually designed a large-scale biofilter, which you can see here. It's pretty much a wooden box that has a pond liner inside, and it follows the same kind of idea, where all you do is you have a large vessel that's filled with bioballs. And so this actually only cost $500, which is less than a fifth of what the commercial option costs. And it's going to have the same capacity and hopefully a comparable nitrification rate. I still need to test that, but I'm hoping that it's going to perform pretty well in the future. So I'd like to thank Joe Kelly, he was my mentor throughout this project, and the rest of the Live Local Organic team for helping me through this project, supplying their guidance and their facilities for me to use. And I'd also like to thank my teachers, especially Abe, for guiding me through the whole summer internship. So thank you for listening to my project.